Hello everyone, welcome back to my channel Mathematics with Miss Jen. For today's lesson, we will talk about radical expression. A radical expression is any expression that include a radical. Like for example, we have cube root of 64. The sign here that looks like a division is called radical sign. And the number inside the radical is called the radicand. And the number on the upper left side is called the index or the root. Please note that a radical also can be expressed in algebraic expression. Like for example, we have 2 cube root of 8x raised to the power of 5. Algebraic, it's because it involves variables. And also, radicals can be expressed in fraction. Like for example, we have 4 square root of 3 over square root of 10. Let's try to simplify the following radicals. Here, for our first 3 examples, we have the indices of odd numbers like 3, 7, and 5. For our first example, we have cube root of 64. So how to simplify cube root of 64? So let's find a number that if you multiply 3 times, it will give you the answer of 64. Because cube root of 64, it's just like 4 cube. Or 4 times 4 times 4. So 4 times 4 is 16. 16 times 4 is 64. So our answer here is 4. And for the second example, we have the 7th root of negative 128. So let's find a number that if we multiply 7 times, it will give us the answer of negative 128. So let's try negative 2. So we have negative 2 times 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 negative 2. 1, 2, 3, 4, 5, 6 times negative 2. So, or we have negative 2 raised to the power of 7. So our answer here is 100. If you multiply this 2 7 times by itself, it will give you the answer of negative 128. So our answer here is negative 2. For our third example, we have 5th root of negative 243. So our answer here is negative 3. So negative 3 raised to the power of 5 is equals to negative 243. So for our last 3 examples, we have the indices of even number. We have 2, 4, and 6. So for our fourth example, we have square root of 64. So square root of 64 is 8 because 8 times 8 is 64. And for our next example, we have 4th root of 625. So the answer is 5. So 5 raised to the power of 4 is 625. And for our last example, we have a special case here. Here, just remember, if our index or the nth root is even number, our radicand must be a non-negative. So non-negative meaning it's always be a positive if our index is even number. So since here in our example, we have the radicand of negative 729, so our answer here is undefined. We cannot get the real root number. Let's try to simplify the radicals using factorization. We will use only factorization if our radicand or the number inside the radicals is not a perfect square. So let us find the factor that has perfect square. So for example, for 72, the factors are 36 and 2 because 36 is a perfect square. So let's simplify. Square root of 36 is 6 and then the square root of 2. And for our second example, we have square root of 80. So square root of 80, the factors are 16 and 5 because 16 is a perfect square. So square root of 16 is 4 and square root of 5. And for our next example, we have square root of 75. So the factors of 75 that has perfect square are 25 and 3. So let's simplify. Square root of 25 is 5, square root of 3. So this is our final answer. Let's try to simplify radicals that expressed in fraction. So here we have square root of 50 over square root of 18. So let's try to find the factors of 50 that has perfect square because 50 is not a perfect square. So what are the factors? We have 25 and 2. And for our 18, we have 9 and 2. And as you can see, they have common factors which is 2. So let's simply cancel them out. So our answer now is 5 over 3 because square root of 25 is 5 and square root of 3 of 9 is 3. So let's simplify 5 over 3 into mixed numbers. So we have 1 and 2/3. For our next example, we have square root of 108 over square root of 45. So the factors of 108 that has perfect square are 36 and 3. And for 45, we have 9 and 5. So let's simplify. Square root of 36 is 6, square root of 3. And square root of 9 is 3 and square root of 5. But we can simplify the coefficient because 6 divided by 3 is 2. So our final answer here is 2 square root of 3 over square root of 5. And for next example, we have square root of 28 over square root of 63. So for 28, the factors are 4 and 7. And for 63, we have also 9 and 7. So canceled out the common factor and simplify square root of 4 over square root of 9. So our answer here is 2 over 3 or 2/3. Let's try to simplify the radicals expressed in algebraic expression. So we have square root of 162 x squared y to the power of 5. So again, let's find the factors of 162 that has perfect square. So which is 81 and 2. X times x squared times y squared squared times y. So we already factored the y raised to the power of 5. So our answer here is 9x y squared square root of 2y. So here, we canceled out the square root of 81 is 9. So for our x here, we canceled out the squared sign because this is squared, so it's also square root. So we canceled it out. So what remains is x. And for our y, we canceled out the squared sign and what left inside is y squared. And the number inside the radical is 2 and y. So that's why we have the final answer of 9x y squared square root of 2y. And for our next example, we have square root of 50x raised to the power of 10 over square root of 2x to the fourth power. So here we will apply the law of quotient. So in division of exponent, we just subtract the exponent. We don't divide, but we subtract. So 50, a square root of 50x raised to the power of 10 over 2x raised to the power of 4, we have square root of 25x raised to the power of 6. Because 10 minus 4 is 6. And 50 divided by 2 is 25. So now let's simplify. So we factor the x raised to the power of 6 so that we can get the answer. So the factor of x raised to the power of 6 is x cubed squared. So to cancel out the squared sign, because it's square root, so we have left here the final answer of 5x cubed. 5 here because the square root of 25 is 5. Remember, if the index n is even, the radicand must be a non-negative for the root to be a real number. If the radicand is not a perfect square, use factorization method and use the factor that has perfect square. Thank you for watching. Please subscribe, like, and share, and click the notification bell for more updates. Thank you. See you next time.